Now we will continue with similar triangles what we have left last week. We will do some more theoretical problems, then after that we will do numerical problems. Prove that any line parallel to parallel sides. Okay, this already finished. If three or more parallel lines are intersected by two transversal, listen the question carefully. If three or more parallel lines are intersected by two transversals, now we are going to discuss similar triangles, so that's why I am erasing that one. Now what we have to do, three or more parallel lines are intersected by two transversal. Let us take three parallel lines, which is L, M, N. Three or more parallel lines are intersected by two transversals. P, Q. May I know what do you mean by transversal? This is a basic 6th class transversal. What is the meaning of transversal? Transversal means a line which intersects two or more lines at different points. A, B, C. Two or more lines at different points. They need not be parallel lines. Here it is, in this case it is parallel lines. D, E, F. Transversal means two or a line which intersect two or more lines at different points. Different point means here A, B, C. Two or more lines. P is a transversal to LM, N. So what is saying? Prove if three or more parallel lines are intersected by two, prove that the intercepts made by them on the transversal are proportional. Prove that the intercepts made by them. What are the intercepts? AB and BC are the two intercepts. Prove that the intercepts made by them on the transversals are proportional. These are the intercepts. They are making, what is saying? They are proportional. Prove that the intercepts made by them on the transversal are proportional. So very simple, students. AB by BC is equal to DE by EF. He is asking to prove this one. Once again, I will read out the question. If three or more parallel lines are intersected by two transversals, three or more parallel lines are intersected by two transversals, prove that the intercepts made by them, on the transversal are proportional. Very simple. Join this. Mark this as A, B, C, D, F, something G. Proof. Consider triangle ACF. Consider triangle ACF. What do you notice in this triangle? So this is a triangle I need to take. By BPT, basic proportionality theorem, if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. This line is parallel to this side, so AB by BC is equal to what? AG by GF. Next, consider this triangle, this one, ADF. Consider triangle ADF. What do you notice? ADF. In this triangle, this line is parallel to this one. M is parallel to L. You can write by BCD. You can also write here M is parallel to N. Like that also you can write. Consider triangle ADF. M is parallel to L. So if a line is drawn parallel to one side of a triangle, it will divide the other two sides in the same ratio. This one, AG by GF is equal to, we are coming from here, bottom, AG by G is equal to DE by EF. DE by EF. Now mark this as, you can write here by BPT, basic proportionality theorem. Now combine these two, AB by BC is equal to, what is in place of AG by GF, we can write DE by EF. Therefore, they are proportional. That's it. Hence the theorem. Simple. We have applied basic proportionality theorem. I have considered this triangle. So I have applied basic proportionality theorem. AB by BC is equal to AG by GF. Now I consider triangle ADF. Use the same principle here. AG by GF is equal to DE by F. Club these two. Why we have to club these two? Because AG by GF is nothing but DE by F. Therefore, AB by BC is equal to DE by EF. That's it. Next question. This is theoretical problem. Let us finish up one or two. Then we'll go to numerical problem. X is any point on the diagonal BD of a quadrilateral ABCD. This is another problem which is of theoretical problem. Next problem onwards we will be moving to numerical. So X is any point on the diagonal BD of a quadrilateral ABCD. X is any point on the diagonal BD of a quadrilateral ABCD. BD. X is any point means I want to take here X. X is any point on the diagonal BD of a quadrilateral ABCD. XY is drawn parallel to DA. XY is drawn parallel to DA. That means this XY is drawn parallel to DA. Next, to meet AB at Y. Already given. XY is drawn parallel to AD to meet AB at Y. Next, XZ is drawn parallel to DC. XZ is drawn parallel to CD. DC to meet BC at Z. XZ is drawn parallel to DC to meet BC at D. To meet BC at Z. Now what is asking? Prove that YZ is parallel to AC. Prove that. Now you have to join all these two. Prove that YZ required to prove YZ is parallel to AC. Yeah, YZ is parallel to AC. How will you prove this one? Now consider this triangle. What you can say? Triangle ABD. Proof. Consider triangle ABD. What do you notice? This ABD XY is parallel to AD. Apply basic proportionality theorem. If a line is drawn parallel to one side of a triangle, then it will divide the other two sides in the same ratio. That means BY by AY is equal to what? DY by AY. This triangle I am considering. BX by XD. Right? Now consider this triangle. This is over. By why we are tried like this? By BPT, basic proportionality theorem. If a line is drawn parallel to one side, it will divide the other two sides. Means these are the other two sides in the same ratio. By y is equal to bx by xt. Next, consider this triangle BCD. BCD. XZ is parallel to CD. Next, what you say? Bx by xd. Since this is parallel to this, you can write bx by xd is equal to bz by zc. Bz by cz. Right? By BPT. Next, combine these two children. What mark this as 1? Mark this as 2. By ay. Bx by xd. What is bx by xd? Bz by cz. Now by ya is equal to bz by zc. In this triangle, consider triangle ACB. In this ACB, from 1 and 2, you can write it as from 1 and 2. Consider triangle ACB. In triangle ACB, already given by ay is equal to by ay is equal to bz by zc. Bz by zc. So, since the ratios are same, what can you say? What is the converse of basic proportionality theorem? If a line divides the other two sides in the same ratio, then that line is parallel to the third side. This line is dividing the other two sides in the same ratio. These are the other two sides. By y is equal to bz by zc. That means this line is parallel to this one. Therefore, yz is parallel to ac. Since converse of BPT. Converse of BPT. That's it. We have proved that. See here, yz is parallel to AC. Very simple, students. So I have considered this triangle. I have considered this triangle. Next, I have considered this triangle. Therefore, hence the theorem. Very, very important this one. Now let us go to another problems. Next, numerical problems. Already I said this is for state, Cbse and Icse. Any one of them can listen this class. I am teaching from all the textbooks so that you would be having complete exposure to similar triangles. So I think that one textbook is completed and now we are going to do another textbook. ABC, in triangle ABC, DE is parallel to BC. Already they have given this one, they have given the graph diagram also they have given. ABC, DE is parallel to BC. DE is parallel to BC and AD by DB is equal to 3 by 5. AD by DB is equal to 3. AD by DB, I will write here. AD by DB is equal to 3 by 5. We are doing numerical problems and that too basic proportionality theorem. So all theoretical problems I have completed. Now for 2 to 3 or for at least 4 classes I may be doing these numerical problems based on similar triangles. So this is very simple compared to theoretical problems. Numbers are given, just you need to replace, that's it. So what is asking? AD by DB is equal to 3 by 5. AC is equal to 5.6. AC is 5.6. Find AE. Question mark. So how will you do this, children? How will you do this one? Basic proportionality theorem. If a line is drawn parallel to one side, then that line divides the other two sides in the same ratio. First you write down that one. By BPT, AD by BD is equal to AE by EC. Now AD by DB, AD is what? Just replace here. 3 by 5 is equal to AE by EC. AE by EC. Now here let us consider this total length is how much? 5.6. Consider this as x, consider this as, or let us say consider this as AC is given, no? AC is 5.6. So let AC is equal to, AC is 5.6 given, AE plus anything else they are given. This, how will you get this 5.6? AE plus EC is equal to 5.6. Mark this as something like this, you mark this as, this is x minus 5.6. Or else do one thing. Mark this as x, this is 5.6 minus x. That will be better, because when you add these two, 5.6 minus x plus x will get cancelled. This is 5.6 total length. So you can write 3 by 5 is equal to A. You can write A something E. Let C is equal to x. Then AE is equal to 5.6 minus x. Why? Because when you add these two, what you will get? 5.6 minus x plus x. So 5.6. So I want to use this one. Let C is equal to x, then AE will be 5.6. You replace here. AE is what? 5.6. AE 5.6 minus x by EC. EC is nothing but x. Cross multiplication. 3x is equal to 5 into 5.6 minus x. 3x is equal to what? 5 into 5.6 minus 5x. Right? This you bring here. 3x plus 5x is equal to 5 into 5.6. It is 8x is equal to 5 into 5.6. Next, x value, calculate x value from this. X is equal to 5 into 5.6 by 8. This one, cancellation. Here it is 5.6 now. So multiply, you remove the point. 5 into 56 by 10 into 8 will come. 8 7s are 56. 5 1s are 5 2s are 7 by 2. That is nothing but 3.5. So x is 3.5. This is 3.5. Now this one is simple subtraction. 5.6 minus 3.5. 2.1. Now add these two, you will get 5.6. So AE is nothing but 2.1. 2.1. CE is equal to nothing but 3.5. So numerical problems are very simple. I am writing step by step. From next problem onwards, I will be doing little bit fast. So since this is the first problem, I am writing all the steps, and that's it. This is another problem. Next. Is it clear? you should apply basic proportionality theorem. Just replace the value. Total length is given as 5.6, because see this here, this is 5 is big, so this should be big, so that's why I have written x. This 5.6 minus x, because this is small now, so 5.6 minus x. After calculating x value, you should subtract. That is how you should get the knowledge. So here you should take x, here you should not take x, because this is small, so this is big, compare this x. Like this you should do the problem. So we did 3 problems. In the next class we will be doing more problems, so numerical problems. Thank you students, have a nice day, bye.